complex fractions. It's just a fraction over a fraction. So if I have something like a over b over c over d. A fraction bar is a division symbol. A division symbol is a fraction bar. It's the same idea. You have a line and then you have the two dots. Well, those two dots represent numerator and denominator. Who knew? Hi, I'm Sarah. I have been a math and science teacher for 20 years, and I'm here to make math engaging and fun. If you are interested in tutoring sessions, or if you have questions or comments or anything like that, click the link and do the stuff. When somebody finally pointed out like, oh yeah, the division sign is just a fraction bar, I was like, it is. So if you're dividing by a fraction, right, we just multiply by the reciprocal, or keep, change, flip, right? So A over B divided by C over D, same idea as A over B divided by C over D. And we've gone over this, right? We do this all the time. Keep, change, flip. It's the same thing as A over B times D over C. We keep, change, flip. Now, again, those of you going into pre-calc, those of you going into calculus, algebra 2, all of that kind of stuff, a compound fraction is still keep, change, flip, okay? So in this case, let's start out with a doozy of a problem. So we've got, on the top, we've got a cubed plus b cubed over a squared minus b squared. That's just the top fraction. The bottom fraction is a squared minus ab plus b squared over a squared minus 2ab plus b squared. We're doing math tonight. All right, so again, it is a compound fraction or complex fraction. We keep, we change, we flip, right? It's the same thing as divided. It's this fraction divided by this fraction, so we keep, change, flip. Now, since we're looking at polynomials, when we're looking at these things, and especially like if your teacher keeps, like if you just learned about factoring, something like that, not something like that, but that, keep an eye out for things that you can factor, okay? When we're looking at these complex fractions and these polynomials and quadratics and all of that kind of stuff, you want to make sure that you are keeping an eye out for things, looking for factorable quadratics, right? Looking for difference of squares, looking for difference of cubes. Hint, hint, that's what we're looking for here. That's what we're looking at here, right? So a cubed plus b cubed, a squared minus b squared. We're looking at cubes and squares. We're looking at the difference in cubes and the difference in squares. That's where we're going with this, okay? So difference in cubes and difference in squares, the difference of squares is sum of cubes. The sum of cubes, so this is just basically like the formula for sum of cubes. This is going to be the same thing as you take a plus b, and like, I am looking at this formula. Like, I do not have this memorized, okay? But I recognized it, okay? So I recognize it, and then eventually, like when you work with it enough, you're going to have it memorized, right? Or you're going to start being able to recognize it. A squared minus ab plus b squared, okay? Looking a little familiar, right? Okay. And then we've got the difference in squares, right? So the difference of squares, we've got a plus b times a minus b. That's the one you see way more frequently. That's the one that you have memorized, right? So a plus b times a minus b. If I foiled this out, sorry, I keep turning this. If I foiled this out, right, they would all cancel out, right? I have a squared here. I have a times negative b, so that's negative ab, and then I have b times a, which is positive ab. Those are going to cancel out, right? A negative ba and a positive ba, they cancel out, and then I have negative b squared. That's where this is coming from, okay? So there we've got these, and now here I've got a squared minus ab plus b squared. That looks awfully familiar. That is that. Okay. Now another thing that I'm looking for, so I'm always looking for stuff that I can factor. I'm always looking for stuff that I can cancel out and all of that. So this one, thinking ahead, I'm going, that is going to cancel out with that. This one here, I go, you know what? A squared minus 2ab plus b squared, that's the same thing as a minus b times a minus b. So I've got a squared. I've got negative ba, positive b squared. So once I've got these all simplified, and well, not really simplified, but once I've got them all factored and I'm ready to go, now I am going to, this table is full, this thing is full, okay? Now I'm gonna take this top fraction and I'm gonna multiply it by the reciprocal of the bottom fraction. All right, so I'm gonna take the top fraction, I'm gonna multiply it, I'm gonna flip this one, I'm gonna multiply it, okay? Moving on up. Okay, so let me recopy this stuff in the black marker because it's easiest to see. So what I'm going to do again is I'm not gonna rewrite this whole thing. I'm just going to write this top fraction and then multiplying by the reciprocal of the bottom fraction, okay? Because that's what we do when we're dividing fractions. Keep, change, flip. We multiply by the reciprocal. Again, the deal hasn't changed, right? The pattern doesn't change. Okay, so I've got the top fraction, which is a plus b. I gotta write this smaller because that's gonna run out of room. Okay, so I'm just rewriting this, a plus b times a squared minus ab plus b squared over a plus b times a minus b, okay? So this is this fraction factored out, right? That's all it is. So I took this a cubed plus b cubed, I factored it out. A squared minus b squared, I factored it out. And the whole reason I'm factoring it out is because with factors, I can cancel stuff out. And it's going to simplify everything. Now I'm multiplying it, and I'm just using the x, so we're sure that we're multiplying. I know it should be a dot, but it's also kind of hard to see on the screen, okay? And I'm gonna flip this bottom fraction. So on the top is going to be my a minus b times a minus b over my a squared minus ab plus b squared. Okay, now we did all this writing, we did all this work, and we get to just start canceling stuff out. So let's do it. The reason we can cancel stuff out, remember the whole root of canceling things out is when you, like any number or value over itself is 1, okay? So when I multiply these things together, I'm gonna have a plus b times a squared minus ab plus b squared times a minus b times a minus b over a plus b times a minus b times a squared minus ab plus b squared. So if I have two things, if I have the same values on top and bottom of each other, right, I can cancel them out, okay? So let's start canceling, right? So I know, look at this. I already had one that I could have canceled back here. I didn't even notice it. I've got a plus b over a plus b, gone. I've got a minus b over a minus b, gone. I have a squared minus ab plus b squared over a squared minus ab plus b squared, gone. That whole crazy, bonkers, complex fraction, a minus b, done. That's all it is. That's really mathed up.